So comets seem to be out. How about if we just take two big objects, 100 kilometers across, and smash them together? That's surely going to make a lot of dust.
Well, this is how dust comes about in our own solar system. You smash asteroids together typically, and that produces dust. So this seems like a good idea. We just take some big rocks, bang them together, and we keep supplying dust.
But we're going to have to keep doing this because whenever we make dust, it doesn't stick around for very long. So that means we're going to have to crash together a lot of rocks.
That's true. But one rock can have a lot of mass, and it won't show up in the infrared because it's not blocking very much of the light. So in fact, we could have a situation where most of the mass is in a few big things, few being like a few billion,
Yep.
and they have very rare collisions, but each collision of two things 10 kilometers across will produce absolutely enormous amounts of dust. So you probably could get away with these things going on for hundreds of millions of years, slowly grinding down the big collection where most of the mass is to produce a constant supply of small dust things that then get blown away.
But I thought this is how we ended up making planets in our own solar system, where they come together and form big things.
Yeah, that's the problem. I mean, we just talked about how you had lots of rocks going around, but instead of smashing them to make small things, we joined them to make big things. Why doesn't that happen? Why don't the asteroids fuse together to form planets?
Yes.
That's what we believe happened to produce the Earth, after all. Well, if the objects were all moving around in nice circular orbits all the same, then their relative speeds would be very slow. So that means their gravity probably could push them gently together until they merge and form big things. And if they did collide, it would be a very gentle collision, like two pillows gently merging together, and so it would make something bigger. So obviously can't have something like this. We need them to be having more chaotic, crazy motions so they bang into one another.
So we don't want them to get organized. We need it to be anarchy so that when they come together, they're smashed. We get all the dust. And so we really need to keep anarchy going and don't allow this sort of organization where we don't have those collisions.
We want just the right amount of anarchy. If you have too much anarchy, all the big things will smash together and produce a huge amount of dust that gets blown away, and that's the end of it.
Okay.
So we want sort of mild anarchy.
Okay.
And how do we do that? Well, we need to stir these up, as you say. And the obvious way to do that is just what happens in our own asteroid belt, which is to have a planet nearby. Our own asteroid belt hasn't coalesced to form a planet because there's Jupiter just outside it, and Jupiter keeps it stirred up enough that it can't all coalesce. So maybe that's what we need. And there's a bit of evidence there are planets near these things. For example, if you look at this image of Beta Pictoris, the disk around it, if you look closely, you see it looks like it's a sort of a bit of a slanty bit coming up.
Yeah, there's a little flare there. So that's saying maybe there's a little planet stirring things up.
Yep, so this is a warp. So maybe there's a planet on an inclined orbit that's pulling it up on this side and down over there, or something like that.
Okay. Do we see anything like this in other systems that we can see better?
Well, here's Fomalhaut, and in this case, you can see when you image it, once again, there's a coronagraph blocking out the light from the middle. This is, again, a Hubble Space Telescope image. You can see the dust is actually in the form of a ring,
Okay.
which is a bit weird. You'd imagine it to be all the way in and out. So it could be that there's, in fact, a planet inside the ring, which is clearing out the dust in the inner bit and keeping the ring stirred up.
Okay, so that is a potential way to solve our problem.
And there's a third, Epsilon Eridani, your favourite star. In this case, we actually know there's a planet there because of the radial velocity approach. It's a little bit controversial, but it seems from radial velocity there is a planet which has an orbit just inside this ring of dust that we can see.
Okay, and so this is an image taken in essentially sub-millimeter in that, somewhere between radio and infrared. And there's a little hole in the center where the planet seems to be clearing things out directly. So, again, it seems to be holding together that these debris disks are something a little different than what we have in our own solar system, or maybe they're a much bigger analogy to what we see, where things collide, come together, it's very violent, and we can keep on making dust, which reflects, and we can see here on Earth.